In our previous videos, we explained that our user may not have enough privileges. We also discussed that how we can use UAC bypass if the user in the administrators group, the local administrator group. This is a kind of common mistake as we discussed. Local admin users are quite common in large networks because of their laptops or configurations. However, we need more, such as system level privileges, not administrative level privileges. Let's focus on this system now, because Metasploit will need system token, and get system, as we can see in our previous videos, is not efficient and it's not working flawless in this Windows 10 environment. So we will use another trick here. First of all, let's do our UAC token escalation. If you remember in our UAC video, we already have copied some files. We already have added some registry keys. This is the new session. After a reboot, we started with a new implant. So what we tried to do here is using STC-LT UAC bypass to get additional privileges. I executed this again and we received a new implant. Our first implant has only these privileges. And I'm going back and using the new implant. This new implant have more privileges. However, we have an issue here. Those privileges are there, but we don't have system token. But system token is the key for some of the Meterpreter functionalities. So what we can do is focusing on that part, because normally our user is shown as Greedo still. So we will use this implant, the privileged one, with a tool. The tool is here. The tool is developed by this user, and it simply creates a new process with the system token and stealing it from another process. And this another process could be, of course, a process which has system token. We know that LSAS always has this process token because it runs as system. So our Meterpreter sessions are there. So I'm just jumping one of those and using PS to get the process list. Sorry, our Meterpreter sessions may not be responsive because we had a reset here. So let's create a new Meterpreter instance and then work on it. Okay, this is our privileged user, and we are triggering a new Meterpreter, and new Meterpreter is arrived. So the Meterpreter arriving last, which is 4, is our Meterpreter. It is responsive because we just injected this, and I'm giving PS. PS will give us the process list, and some of those content unfortunately not reachable to us because we don't have enough privileges. This data can be read by system. But this one, we know that LSAS is running as simply as system. So we are going there to run this system. And if we remember the application and how it works, we will need to import this PowerShell, and then we can give this command. The command is simply calling this function with the PID and command itself. So let's try this. If we will upload this to the system, we can use native PowerShell, of course. But we don't prefer this technique. We prefer our PowerShell automation. It is less restricted. Still monitored, but less restricted. How we do that is using exec PowerShell automation, using file parameter, and this one is the PowerShell to include. So it will import this PowerShell, and then the command is here. The command is slightly simple. The process ID taken from else right here, process ID, the command, the executable to run, the process to start, and /c will run the command given. The command is actually the batch file we have uploaded that is used for registry as well as privilege escalation. So let's see whether or not this will work. It says that handle PPID, parent PID, updated proc attribute, starting cmd.exe and cmd.exe popped up briefly, and we have an event plant. Let's go back and get a list. Okay, the new implant has the username of NT Authority System, which is what we were after. Now we have system token, and we are actually the system user. But we need to transfer this to Meterpreter, right? Because Meterpreter is using it. So we need to create a new Meterpreter in this case, and injecting our shellcode back again. And this will give us a new Meterpreter here. So I'm going back and cleaning the screen. Our sessions were three dead and one alive session, the fourth one. And we are just adding our command here. It is simply running Meterpreter. Process injection has another issue here, because process injection is trying to use Internet Explorer as user injection. It doesn't use system injection. We need to run something else to inject this. So we can use our inline shell as well. Let's try that one. So simply exec sharp assembly and use this inline. This inline is slightly different because it doesn't inject the code to a remote process. It does run it in our own process using virtual alloc, Marshall copy to push the data in memory, and then working on the thread and running it. We need to give a raw URL or a file to run, so it will run the content as we imagine. So let's see whether or not this will work. So exec sharp assembly will accept some parameters. One of those is URL. And we can give this URL there as well. However, we will use file to get the compiled assembly, then giving the parameters to the compiled assembly. This is the assembly, and it accepts raw URL. And finally, Meterpreter payload. Okay, let's take a pause and cleanly explain our steps. We tried a process injection already implemented in Patak. It didn't work because we are using system user, not any normal user. That means system running Internet Explorer and injecting data will not be easy. We need to run this in its own context. That's why we are actually looking for another type of injection. In this case, I use another injector I developed, which is using simple code execution. Virtual alloc, create thread, and wait for single object will be our pinbox, and it accepts some parameters. For example, raw URL and raw file. And if URL is given, it will download the content and it will run the content. Run is quite simple, opening a new memory space in read write execute, push the data, and creating a new thread and waiting for it. So this has a compiled version here as well, executable, and I will ask Patek implant to execute this compiled assembly with the parameters of raw URL and Meterpreter payload. So I will hope that this will run some code for us. It says that use demo raw URL or HTTP. Of course, my bad. I need to give the HTTP link. HTTP link is HTTP, our IP address, the Patek service IP address, tools, and the Meterpreter payload. Lucky us, the Meterpreter payload was also served under www and tools SM. So this can be still useful for us. We started that and we received a new Meterpreter. And the session is anti-authority system. I will repeat this again because it looks complicated. I fixed a lot of different problems on the way with you live. First, I received a user as normal user, and I use UAC to get the UAC bypass, and I got additional privileges. So my user had additional privileges, but this was not sufficient for Meterpreter. I needed something else. So I needed to elevate my privileges. Actually, I need to steal the token of system. I found another application on internet, which is this application on GitHub repository of Decoder IT, PSG system PowerShell. And I used exact PowerShell automation feature of Patek to elevate my privileges, which means as user, as administrative user, I stole the token of system, simply importing this PowerShell and asking it to use 720, which is the process ID of LSAS. We found this through our process list on Meterpreter here. Then calling our initial script, which is UBP-BAT. We use this as persistency here as well. So it started and it actually arrived as a new user, which is anti-authority system. So we looked for a way to transfer this to Meterpreter, which is another Metasploit framework, another application, totally different. It's not easy to implement this and transfer between the applications. That's why what we need to do here is running the Meterpreter starter in this context, the anti-authority system context. So I jumped exec shellcode in that context, and I simply asked the Meterpreter payload to be injected. It failed. It failed because the injector type is designed for the users, not for system and other processes for now. The problem is it injects to the Internet Explorer. And Internet Explorer is system is not a great idea. That's why it didn't work. That's a kind of fix for me, and I will fix this anyway. And I decided to use my standalone injector. And I show its source code to you. It simply injects the source given shellcode to current process. It simply uses virtual alloc to open a new memory space. It pushes the shellcode and then it creates a new thread and runs it. And I had this source code compiled as well, and that's why I use the compiled source code under scenarios and file section, shellcode invoke inline. This inline executable is a .NET executable, so Patak can run this as a .NET assembly. Exec sharp assembly as file would work for us. And we know that when this application runs, it will require two parameters. The first one is raw URL or not. The second one is this one, the Meterpreter URI, the shellcode URI. The shellcode in raw format was also in our tools folder, so I gave that link. In our previous videos, we have used this link as well for remote deployments. And it started the token. Actually, it started the process. It injected this shellcode and ran it in the same context. That's why we received a new Meterpreter session here. And the Meterpreter session is simply NT authority system. So we have the system token now, and we will build our attacks based on the system token.